problem. Okay, great. All right, so today for this month's webinar series, we have Dr. Isabell Adler, who works in the field of evolutionary biology education. She is affiliated with the Bern University of Teacher Education, and the title of her talk will be Assessing Kindergarten Children's Ideas about Evolution, Insights and a Tool. However, let me introduce Isabell first. Isabell graduated from Kiel University in Germany with a degree in biology education. She then completed the PhD at the Leipzig Institute for Science and Mathematics Education in Kiel, where she investigated how kindergarten children's first ideas about evolution can be measured and fostered. In 2023, Isabell moved to Switzerland to work as a postdoctoral researcher at the Bern University of Teacher Education, focusing on how and why teachers use intuitive reasoning when explaining scientific concepts to young children. So we're really, really excited to have you, Isabell. The format is that Isabell will speak for around 45 minutes, and then we'll open to the audience to ask questions or comments before we wrap up and advertise our next webinar for next month. So welcome, Isabell. The floor is yours.
Thank you very much. So thank you very much for the kind introduction, and I'm very excited and happy to be here and to speak to all of you and to see that many names, even though I can't see your faces. But yeah, like I announced in my title already, I will bring to you some insights and a tool that I both gained during my PhD project, which I did in Germany. So even though I use the corporate design slides of the Teacher University Bern, I just want to point out at the beginning of my talk that everything that I will talk about was still produced during my time in Germany and was part of the EvoKE project. Yeah, so let's dive right into it. Yeah, having you as an audience, I decided to, first of all, not start with the usual talk about that how important evolution is, and that it is the central theory of biology, because I'm pretty sure that all of you already know that. However, I would still like to start with a brief, with some words about evolution in education in general. So evolution is considered to be an integral part of science education. And indeed, it is part of formal education in most countries. So here on the right-hand side, you see a table where the authors put together like when evolution education usually starts in different countries around the globe. So we see that in most countries, evolution is first introduced in middle school. Some countries already introduce it in primary school and some in high school. However, we know that regardless of age and regardless of the cultural background, that learners have difficulties building coherent knowledge about evolution in general. So what makes learning about evolution so challenging? Learning about evolution is challenging because the architecture of our cognition favors what is called intuitive theories. So we have already some kind of intuition that helps us navigate through the world. And however, these intuitive theories, they do not align with the concept of evolution. But instead, when we apply them to natural phenomena, they naturally lead to misconceptions. And once misconceptions are established, they cannot be overwritten easily. Instead, learning about counterintuitive topics like evolution is a gradual and very slow process. So this is why some scholars argue, or a growing number of scholars argue, that introducing evolution in high or middle school is already too late to acquire coherent knowledge about evolution. And just talking about myself, so evolution first was introduced to me in high school, so pretty late. And I majored in biology, and I think I didn't really understand it until the end of my master's degree. So it took me quite a while, and I specialized in it. So and it still was like a rocky road to get there. And so now I would now I think that I by now have a solid understanding of evolution, but I know that it's quite a struggle to really get over all these intuitive theories that we have accumulated, or that we accumulate across our educational journey. So by integrating the topic of evolution early in the curriculum, we hope that we could decrease the establishment of misconceptions, and also over time build robust representations that can resist the competition of intuitive responses. So this was basically the idea that I had when I started my PhD project. So I knew that I wanted to somehow foster children's ideas about evolution. And I wanted to design educational materials in order to foster these ideas. So when I started researching, of course, I first made myself comfortable with the current research back then. And here I gathered for you like the studies that I found during my initial time in the project. So here I gathered all the different studies, and I sorted them by the evolutionary principles, variation, inheritance, and selection. I also somehow ordered them a little bit by age, so kindergarten age and elementary school age. And if you would now take a closer look at the studies, you would find that most of this, or that all of the studies focus on a very specific, or most of the studies focus on a very specific aspect of these, of the principles. So for example, the studies would address individual variation, or they would address the origin of species. But when I started, there was until then no systematic analyses on children's ideas about evolution. Also, what you might have already realized, because I also sorted them by the example species that they used in their assessments or in their research. And you can see that especially for kindergarten children, there are no studies on their ideas about plants. And this was kind of surprising, because we know that context factors influence learners' elicitation of knowledge and my literature search, or my literature review, was that children can understand aspects of variation, inheritance, and selection. And there is a growing number of studies that show that by implementing interventions. We also know that children's beliefs, as well as adults' beliefs, are influenced by intuitive explanatory patterns. And we know that children hold different ideas and biases about plants and animals. And this has not been investigated in the context of evolution, but it has been investigated in the context of living, non-living distinction. So usually children would tend to consider animals to be more alive than plants. This is because they identify aliveness by movement. And since plants move much slower than animals, they believe plants not to be as alive as animals. Okay, so this was the first thing, but then when I was thinking design an intervention, I already came to the point where I realized, okay, we would also need an assessment that I could do before the intervention and after the intervention to see if I had produced some learning gain in the children. So that was when I realized that I would also need to measure the children's ideas. And this is the second part now. So I knew from my studies that there is a plethora of standardized assessment tools in biology education, and especially in evolution education. However, all of these assessments are designed for students, or for literate students or adults, because most of them are paper pencil tests. So here you just see a selection of such standardized assessment tools, like we have the BCI, the Acorns, the CANS, the K-Evo 2.0. However, for children, there were no standardized or validated assessments to measure their ideas about evolution. Instead, like I already mentioned, most studies focus on a specific aspect of evolution, and also the format is usually individual interviews with the children, but there are no standardized assessments until now. Okay, and maybe you already realized, but what I always consider as to be very important is also the use of the examples. And when we compare the assessments for students and the interviews for children, we see that usually standardized assessments use examples from both the animal and the plant kingdom, while, as I already mentioned, the research on children's ideas about evolution exclusively or nearly exclusively focuses on animal examples. Okay, so this is now kind of the outline for my talk today, because I will present to you the studies that I've done to address these issues. So first of all, I did an interview study in which I systematically analyzed children's ideas about evolution in the context of both plants and animals. And then I took this interview, the study is already has already been published. And then I took this interview and standardized it or transformed it into a standardized assessment tool, which I called, which stands for Conceptual Assessment of Children's Ideas about Evolution. And I will also quickly present to you its development and the validation. And then finally, I also did an intervention study where I tested where I put the Casey into use, and I tested 2 different children's books with the Casey, but this will only be outlook at the end of my talk, and I will not really go into detail with this story, with this study. Yeah, but let me start with the first study. So this study I did together with my mentor, Daniela Fiedler, and with my supervisor, Ute Harms. And I was really glad to see, or delighted to see, that the photos that they had online, that they perfectly matched the color scheme of this talk. So this really matches well with the colors that I chose. And like I said, the study has already been published. And if you would like to have a look at the study, then you can find in the upper right corner, you find the QR code, which you can scan to access the study. So the questions that we addressed in this study were what ideas children hold about variation, inheritance, and selections, and what context-dependent differences they show in their ideas regarding or between animal and plant examples. And first of all, when I designed or when I developed the interview, I used a conceptual framework that consisted of 9 evolutionary key concepts. So you already heard me mentioning them, but we always rely on these 3 principles: variation, inheritance, and selection. But you can further subdivide these principles into corresponding key concepts. So for variation, that would, for example, be origin of variation, individual variation, and differences in fitness. For inheritance, that would be reproduction and inherited variation. And for selection, it would be limited resources, differences in survival and reproduction rate, change in populations, and speciation. And usually studies in evolution education would use varying numbers of these concepts. So some studies would leave some of the concepts out or would use other concepts. But so this is a framework that is often applied in our research field. And then for each of these concepts, I developed questions, either by adapting items of published assessment tools or by designing interview questions, or by adapting interview questions, or by creating completely new ones. And then I made sure that all of the questions could be applied to plant as well as animal examples, and I chose a balanced number of animal and plant examples. So I chose 3 animal species and 3 plant species that belong to different biological and folk biological categories. So in the end, we had the brown-lipped snail, the hooded crow, the red fox, the eagle fern, the dandelion, and the apple tree. And with the help of a graphic designer, we designed 49 illustrations that we used as visual prompts during the interview. And these, and we made sure that the pictures reflected variation, because usually when you, especially in studies in psychology, researchers would often use very simplistic drawings where, for example, if you talk about variation, where you would only alternate like one trait, but the scheme would, or the figure would completely look the same. However, we wanted to make sure that we are talking about real animals, and and that's why we chose this realistic design that is full of variation. And these figures or these images helped us to support the communication. So first of all, they served kind of as a conversation starter, and it also helped the children. For example, they could point at the pictures, or they could use them to support the verbalization of their ideas. And also, they helped us to visualize complex relationships, because we did not ask for declarative knowledge, and we could not use scientific terminology. So we had to put or translate the concepts into contexts, and especially when we talked about selections. So these are processes that imply multiple factors, or that are influenced by multiple factors. So we also use these illustrations to narrate the stories, to then give a face to these concepts. So once the interview was ready, I collected the data doing individual interviews with kindergarten children aged 5 to 6 years. Before going into the field, or the first step while going into the field, was that I did 3 pilotings with 3 children each, where I could use the data and my observations to then again revise the interview again. And then the final sample consisted of 24 children. And these interviews were audio recorded, and that resulted in a total of 14 hours of interview material that we then transcribed and did a qualitative content analysis on. The category system that we used was developed during piloting, and it comprised, for each question, it comprised 3 levels. So in that we followed the example of Andrew Stuhlman in one of his studies, and the 3 levels were, so we termed then unscientific, intermediate, and advanced. And for each of the levels we would assign 0, 1, or 2 points. And so that you can get an idea about how the category system actually works, is that we defined 2 criteria. One was the acceptance of the key concept, and the other one was the adequate explanation of the key concept. So if a child did not accept the key concept and also did not provide an adequate explanation of the key concept, then we would assign the score 0. So just to give you an idea or an example, so when we talked about the origin of species, and in this case we talked about the origin of apple trees, we would ask, so what do you think? Have there always been apple trees in the world, or was there a time when there were no apple trees? So what we want to hear is that species living today have not lived forever, but they emerged that they emerged at some point, and how they emerged, or how that they emerged through evolution, for example. And so this child responded, Well, so in the past there were a few, but not as many as now. So the child thinks that at the beginning of the world there already have been a few apple trees, but then, and that they just like reproduce, or that they just grew more over time. So this child does not accept the key concept and did also not provide an adequate explanation of the key concept. That is, we would assign the score 0. If a child would accept or would score positive for one of the criteria, then we would assign the score 1. So an example would be this. So again, we ask, well, was there a time when there were no apple trees? And this child responds, so the child nods and then says, with the dinos. And then I asked, okay, and how come there are apple trees in the world now? And the child says, because the dinos are no longer alive and some have been harvested. And then I ask, okay, so who harvested them? And the child says, a farmer. First he had a seed and he planted it, and then he dug up the apple tree. So this child accepts the key concept, so that apple trees have not lived on Earth forever, but the explanation that it provides, that at some point a farmer had cropped the seeds, is not an adequate explanation for the emergence or the origin of the species. And if a child scored positive for both criteria, then it would be assigned the score of 2, and this could be one example. So this child said, a time when there were no apple trees. And then I ask, so why are there apple trees in the world now? And the child says, because they have developed from other trees. So this is already a very advanced example, but you can see the child accepts the key concepts and also provides an adequate explanation of the key concept. Okay, so now I also brought you a different example, and now you can see if you can, so how you would rate this example. So this is not about the apple tree, but now about the brown-lipped snail, but it is the same question. So we asked, have there always been brown-lipped snails in the world, or has there been a time when there were no brown-lipped snails? And now I would like, so I will read the dialogue, and then I would like you to type into the chat what score you would assign, 0, 1, or 2. So the child responds, there was a time without snails. That was the time with the dinosaurs. There were Stegosaurus and Triceratops and Brachiosaurus. Then I ask, so how come there are snails now? There was a big meteorite, and then there was fire everywhere, and all the dinosaurs died. So this child was very much into dinosaurs. And then I asked, and what about the snails? And then the child says, they got born after all dinosaurs were dead. So now I give you a couple of seconds, and now you can vote in the chat how you would rate this child. So we do a little inter-rating here. Okay. Okay, great. I already see a lot of ones in the chat, and I agree with you. So maybe this would result in an inter-rating reliability of maybe 95. So we also scored this child as 1. So the child accepts that there hasn't been, brown-lipped snails haven't lived on the Earth forever, but the explanation that they got somehow born after the dinosaurs were dead does not count as an adequate explanation of the key concept. Okay, good. So this is just to give you a quick insight into how the category system worked. But I mean, also like not all the examples were always very clear, and I'm pretty sure that we could also discuss about the examples that I showed you, but this is also why we implemented an inter-rating with 25% of the sample, where 2 independent raters, so I rated 100% of the sample, and then a student researcher rated an additional 25% of the sample. And this resulted in an acceptable Krippendorff's alpha. We scored 0.79 with 0.67 being the cutoff value. So higher than that. And to determine whether the children's ideas about plants and animals differ significantly, I implemented a Wilcoxon signed ranks test. Okay, now I will go through our key findings, and first of all I will touch on research question 1, which was about the children's ideas about variation, inheritance and selection. And first of all, I would like to point out that the children already showed a variety of ideas about the evolutionary principles, especially those that were observable in the children's environment. A few children already mentioned evolution or ancestry. However, unsurprisingly, most children lacked knowledge to support their beliefs. So, for example, nearly all of the children assumed that or could explain that individuals are unique or that each individual is different. However, they could not explain the origin of variation. Or also, many of the children assumed that today living species had not lived on Earth forever, but they could not explain how they came to be. And also most children seem to struggle to apply their ideas coherently across different scales. So there was also interesting to see, for example, many children explained that if an individual would lack resources, that the individual would eventually die. But when they had to apply the same concept to a population, where a population would lack resources, they assumed that the population would somehow cope with the stress, for example, by cooperating or by migrating to another region. So that was very interesting to see. Then concerning the research question 2, which was about the context dependency of the children's ideas. So now I will show you a figure that is a little bit complicated, but you can see on the y-axis I have the 9 key concepts, and then on the x-axis you see the average score for, in orange, the animals, and in green the plants. So here you can see that the children surprisingly exhibit pretty similar levels about plants and animals, except for reproduction, which was the only one that turned out to be significant, or where the differences turned out to be significant. You can also see slight differences, for example, in the lower the lower 2, the population and changes in population and speciation. However, these did not result. They did not result as significant. Maybe that was due to the small sample size. However, when we repeated, when we used the interview in the further studies, they did not result to be significant. So yeah, that might be trustworthy, these results. While the reproduction the differences stayed significant also in the other data collections. Yeah, for the reason why the children scored so different for reproduction was primarily because for animal reproduction, most children assumed that it would need 2 animals in order for animals to reproduce. However, for plants, most of the children assumed that either plants would reproduce only asexually. So, for example, that an apple tree would grow an apple that would contain the seeds, and so the tree would reproduce just by distributing the apple seeds. Or what I called abiologically. So a lot of children would also have ideas or explain that seeds would need to be or are produced in a factory, or that humans would need to go to a supermarket in order to buy the seeds of the plants, and that the humans would then plant the seeds in order for the plants to reproduce. And so these are the differences that you can see on a quantitative level. Now I would also like to go into the differences that we could only see on a qualitative level, but that did not reflect in the children's scores. So in general, we saw that the children overestimated the importance of humans for plant life. So this is a phenomenon that we know under the term anthropocentrism, and this reflected in the fact that the children attributed reproduction, like I explained, or survival and speciation to human intervention. And this is something that we only found in plants and not so much in the animal examples. And how we explain these differences is, so first of all, for the asexual reproduction, is the lack of visible movements in plants. So a lot of children would explain that trees or that plants don't have legs, and so they can't move and they can't meet in order to mate or in order to have a family. Also, it might be that children understand families primarily as social constructs of individuals that live together, that care for each other, rather than biological units. So for them, parents are not just sexual mates, but they are social constructs. And for the artificial, or for the ideas around artificialism, this might be because children, or about anthropocentrism, this might be because the children perceive humans as cultivators of plants. So for example, they experience how humans garden, how we keep house plants, or even how we, for example, crop and harvest plants as in agriculture. So that might skew their view on that plants would not be able to survive on their own, but that they need human intervention in order to live. So in conclusion, we can note that that there are little differences in knowledge of animal and plant evolution, but that we concluded that these differences, and especially anthropocentrism, might be something that we would want to address in early education. Okay, so this was the interview study. Now I would like to move to the development and validation study. And this study, again, I did together with my mentor, Daniela Fiedler, and my supervisor, Ute Harms. And for this study, also the psychology professor, Andrew Stuhlman, from Occidental College in Los Angeles joined us. And the study is not yet published, but it is currently submitted. So fingers crossed that I can hopefully share it with you at a later point in time. So the research question that we tried to address was how children's ideas about evolution can be assessed. And like I already said in the introduction, so I used the first version of the interview, and after the data collection, I revised this. So in the first version, we audio recorded and transcribed the interviews, and then we did the analysis and the iterating with the transcript. So that was also a very time-consuming process. And this is also the reason why usually studies in early education or in early childhood have very small sample sizes, because working with children that age and doing interviews is always a very time-consuming or resource-consuming process. However, the final version, in the final version, we implemented the survey in Qualtrics, so that we then had it on an iPad. So here you can see how it looked on a mobile device. And just to quickly point out how it looked like. So above we had always a STEM question. That was a closed-ended question that provided the problem or the context. Then below we had possible follow-up questions. So these were open-ended questions that served for clarification. So usually we would need some more question in order to really get to the core of the children's ideas, or to really make sure that what they said was really what they meant. Then here below you see the picture or the visual prompt that we show to the child, also to provide the context. That also served as a conversation starter, and this was very handy because before I had printed out all the images, and during the interview I would show the 49 illustrations and I had to go them through one by one. And now with the iPad it was much easier just to click and then have the next picture. And then below, and this is very this was very new, and this was a great improvement. We have this drop-down menu where we already included the category system. Again, those are the 3 levels that we used for scoring. So this meant that we could do the coding and the iterating already on site. So we would have the interviewer and an iterator during the data collection. They were both present. Both of them had their own iPads, and they would code the child's responses independently from each other. And this was very handy because by doing so, after the interview, we already had the data coded, and so the interviewer and the iterator's data coded and in a digitized format, instead of having to audio record, transcribe, and then analyze it. So that saved us a lot of time in the data collection and in the data preparation process. What we also did was that we amplified the framework. So before we had 9 key concepts, but we now split the concept of speciation into the 2 subcategories, origin and extinction of species on Earth and common ancestry, because we found that there were that we would need a couple of more questions to really get to the core of the children's ideas about these 2 aspects of speciation. And overall, we reduced the set of questions from 33 questions to 20 items. So we had 2 items per key concept, and that also saved a lot of time during the interview. So the first version on average took 35 minutes, while the final version took on average 18 minutes to do. The data collection took place in 2 phases. So first, we did cross-sectional interviews in the USA. Before going into the field, we again did a piloting with 3 children, and then we collected a final sample of 34 children aged 5 to 8 years. And then afterwards in Germany, I did a test-retest design where I interviewed 14 children aged 5 to 6 years, and I implemented the test twice with a 1-week delay in between. So, and this was to see if taking the test alone would lead to a learning effect. And again, like I said, the interviewer and the iterator were both present during the interviews, so we had an iterating of 100% of the sample. So we used these interviews or the data to gather arguments if the interpretation of the case's findings are valid. And this is, so now we'll shortly outline the arguments that we gathered so far. So first of all, concerning the reliability, we found that the iterator reliability again reached an acceptable level of agreement between the raters. So in the USA, we resulted in a score of 0.85 and in Germany of 0.92, which is a pretty high value already. And the test-retest reliability resulted to be moderately stable, so there is no significant learning gain from taking the test once. Then we related the findings to other variables, and we did not assess many other variables, only the demographics. And we found, as we expected it, we found a significant positive correlation between age and mean score. So elementary school children scored higher than kindergarten children, but we found no significant differences between the mean score and the gender or the nationality, which is good because then it doesn't lead to a better or worse outcome for one of those variables. Concerning the test content, so first of all, we used a validated and well-established theoretical framework to guide the item selection, and we also used published instruments to inform the development of the items so that we could profit from the expertise of other researchers and the validity of other research or other assessments. Also the pilotings, so the 4 pilotings served us to identify flaws and improve the content validity during the development process. And finally, we could observe that the participants gave apt responses and they only asked minimal clarification questions, which showed us that that we used an age-appropriate speech, and that also how we presented the concepts was age-appropriate. And the responses that the children gave were distributed across all levels. So the test is unlikely to produce a flaw or a ceiling effect, because that was also a danger that if we would ask the children about evolution, that it might be too difficult, or that the questions might be too difficult. So in conclusion, the KC was developed to assess children's ideas about 10 evolutionary key concepts, including plant and animal examples. And with the tool, we try to overcome challenges that we usually face in early childhood assessment, like the time-consuming data collection and ethical issues, which are grounded in the whole process behind the audio recording. And the first evidence that we gathered supports the assumption that the interpretation of the KC's findings might be valid. However, there are, of course, also limitations, and these are the limitations for both of the presented studies. So first of all, I would like to point out that all of the findings that I presented to you are based on conversational evidence. And this is a problem, especially when we work with very young children, because what the children truly think, or the ideas that they truly have, might be very difficult for them to verbalize. So it might be that sometimes we did not really get to the core of what they really thought. Second of all, we gathered data from 2 Western countries. However, this and also we had pretty small sample sizes, so this might limit the generalizability of the findings, and this would need further research in order to get a more generalizable view on children's ideas about evolution. And finally, I would like to point out that the KC could still use some more effort to further support its validation. So first of all, what you would usually do is that you would take a comparable tool and then see if they get to the same outcome, if you would test the same person. However, like I said, there are no comparable tools until now and for children that we could use to compare them to, and everything that is available and published we already took that and implemented that in the tool because we used the published interviews, and so we also could not use one of the other approaches because they are very similar to what we did in the end. And another thing that we could do is when we would use an argument-based validation, then we would then you would have to test the test the assessment in an intervention and see if it does its job. However, there's also only a limited number of interventions that we know that already work in kindergarten and where kindergarten children work about evolution. So it's also hard to show the validation of its findings by doing interventions, because we still lack thorough interventions. But now I come to the outlook that I already mentioned briefly. So we already implemented the KC with 2 different interventions. So the first was with a children's books, that is called The World of the Hops. And the other one is a children's book that we designed ourselves that we called The Secret Nocturnal Gardener. And what is outstanding about the World of the Hops is that it covers all 10 key concepts that the KC covers. So it is yeah, it very broadly covers all of the key concepts. However, it also only touches on these key concepts very superficially and very briefly. In turn, we developed the Secret Nocturnal Gardener to address the anthropocentric views of children, or the anthropocentric ideas, and we only covered the principles variation and inheritance, but we used more space, or we got more into depth explaining these two principles. And yeah, these are just like first explanatory studies. That was the first time that we tested the KC in combination with an intervention for the World of the Hops. Unfortunately, we did not get any significant differences between pre and post test. However, for the Secret Nocturnal Gardener, for 3 subconcepts, we found that the children's ideas, or the children's scores, improved significantly from pre to post test. And one of them was sexual reproduction in plants. So this might be some further evidence that it might work in intervention. What I would also like to add is that those two were just short-term interventions where we had a single reading intervention, and probably for kindergarten children you would need more like long-term interventions. Okay, so now I'm at the end of my talk. I would like to leave you with some take-home messages. And during my work, and when I have conversations about my PhD project, I usually find, and this is also something that was reported in research, that young children are underestimated, especially when it comes to complex topics. And this might be the reason why evolution education is usually delayed until middle or high school, because in school, usually the more complex topics are put to the end of the curriculum, and that is why we only have, why the evolutionary education is more like fragmented to these upper levels. However, in my research so far, I found that children already have a variety of ideas about concepts that are related to evolution. I also found that they show similar ideas about animals and plants, which was surprising for most concepts, but that they have stronger anthropocentric beliefs about plants, which would be probably important to address in early education already. So the KC, for my part, was a seminal effort to standardize research practices. However, further research is necessary in order to further improve research methodologies and develop and evaluate educational materials for early education and for early evolution education. But however, by doing so and by further advancing the field, I hope, or I believe, that we can transform how evolution is integrated in the curriculum, and that we might at some point create a curriculum where evolution is implemented throughout the whole educational journey of a child. And if you do so, and if you put effort in this goal, then I just kindly ask you to please not forget about the plants. Thank you.
Thank you very, very much. That was an amazing, amazing talk. So enriching and so relevant and so important. So many lessons, and I'm sure people are thinking in different directions. So let's open the field now. Who would like to ask? Either you can raise your hand and unmute yourself, and if you want to show us your beautiful face and ask a question, or you could put it in the chat. So let's give people a couple of minutes. Who would like to ask? And if I don't see your hand, please just unmute and say, I want to talk.
Yes, I would love to see some faces.
So any relevant questions? Or until people raise their hands, maybe I'll ask a quick question. Isabel, I was fascinated by all your talk. Oh, here we have Zana. You want to ask a question? Go ahead.
Go ahead. I can do it later.
Okay, I just want to follow up. I loved what you said about creating the children's book about evolution. And I wonder, was that published or it was just you made it for your research? What happened to it? And the reason I'm asking is I have a program called We Love Reading. And we also work with children's books as well as reading aloud. And we created a book last year about evolution, about the peppered moth, the typical story of the peppered moth. Excuse me. Yeah, so we'd like to know more about that.
So, okay, I will ask my question afterwards, because I would also be interested if your book is already published. But first of all, that is a very good question. So we hope to publish it at some point. We will now, I think this month, we will publish it, but only in German on the IPN website. But afterwards, we would also like to, give it to some publishers to maybe publish it as a real children's book. However, if someone is interested, like I said, by now it's only available in German, but maybe ChatGPT could do a good job in translating it, or maybe DeepL or something like that. So if someone would be interested in the book, or if someone would like to use it in their research, then just ask me, and I would be willing to send it to you. And now, Rana, please tell me about the peppered moth.
Thank you very much. So I'm putting in the chat, I'm putting the link to our book. Our book is published. When you can go to the link and look at it. It tells the story of a little girl, her mother and grandmother as scientists, and how she discovers the peppered moth. She tries to understand why. So I would love to see later. We can follow up on how you would analyze the different answers that the children imagined, and how then she discovers that all those were not right or silly, and how she comes to the conclusion by herself, and we connect it to biodiversity and climate change. Wow. I put the link, people can look at it. And
yes, thank you very much.
Offline, but thank you very, very much for
that
your
sounds
work.
Good. Thank you.
Zana, your turn.
So thank you, Isabel, for your amazing talk and for your amazing research tool. We also have a valid tool, but in fact, it doesn't include plants. And that's a major problem, I feel. So it's very good that you have addressed that problem and have overcome the problem that we still have in some of our papers, that is to be only animal-based. So thank you very much for that. And thank you very much for also covering a lot of different evolution concepts, because usually what we see, and against me, I spoke, it will be all about natural selection. And in fact, evolution is much more than natural selection. So thank you very much also for covering that.
Yes.
But my question is more related with what should we do from now on? So there's plenty of evidence that you can learn evolution since elementary schools. There are several research groups working in many different countries that have been showing this over and over. And again, we have just recently published the paper in Neurocitizen that shows that most evolutionary concepts are not addressed until at least the 9th grade. And so the question is, how do we change this? What can we do together in order to change what we currently see and actually put the children learning evolution since when they can, and avoid that they develop misconceptions that are then very hard to remove? So
yes.
What do you think about this? What are the next steps?
Thank you for the question. First of all, I would like to answer a question that you did not pose, which concerns the first part of your comment, when you said that most of the items or most of the research always focuses on natural selection. And I think that that is a very good point. And now I will connect it to the question that you really asked, is to validate validate more profound, or like the underlying principles, variation and inheritance, because I think that they serve as a solid base for then later learning about evolution. So only if you understand the importance of variation, or if you understand the origin of variation, then you can understand selection. And only if you understand superfecundity and inheritance, only then you can understand selection. So this is the first thing that I would like to point out, that evolution education does not always have to be about selection, but that it can also be about, for example, individual variation, which is, by the way, a great topic for kindergarten children, because it also teaches us about diversity, and that diversity is inherent to all species on Earth, and that is not something new that we have invented at some point, or that is only unique to humans, but every individual is unique. So I think that that is a great point to start. I think that you could also go the other way and more come around the origin of species and talk about the Earth's timeline, and use, for example, dinosaurs as a good starting point to get the motivation of children. And I think that is, or is, at least that is my experience working with the children, that this is mostly like, that children are very interested in those topics, and that those would also serve as good starting points. However, now coming to your question, how I think we should proceed from here. And I think, like, of course, the research that we do is important and it is seminal work. However, we still fail to translate this to education. And I think one very major thing is that we really need to get to the teachers and to the educators. And I think one way would be by providing attractive material, and not to have an agenda on somehow making all children accept evolution, but more to provide learning opportunities that are sense-making, that are accessible, that educators would support, and that they would like to teach, that it's not so much about a moral or an ethical thing that you should do when you're a preschool educator, that you should teach about evolution, but that we have cool and attractive materials that educators would like to use to teach. Yeah, I think that is that would be my naive view on how to approach this. I think, of course, there would also, we would also need some political changes, probably. I mean, if you change curriculum, usually it needs some time for all, like, to sink in, but at some point in time, education changes, and with changes in the national curricula, school books change, and with the school books changing, also the lessons would change. However, especially for early education, or in kindergarten, especially in Germany, we don't use really school books in kindergarten. That's different in Switzerland. In Switzerland, we actually have school books for kindergarten children. But yeah, that also depends highly on the cultural background. And I think that we also would need some culture sensitive approaches, and would also need to consider differences between the different countries.
Thank you very much. I think you touched several very important things that we need to address. So thank you. We should discuss more about this.
Yes, that's true. I think so too.
Excellent. Are there any final questions or comments? Because we're already over time by at least 4 minutes. So I don't see any hands. I don't see anything in the chat. Julia, you had a comment in the chat. You're talking about, do you want to ask something or talk about it?
No, I only wanted to share my dismay for this comment of our Ministry of Education about the need to study organisms that are all died. What's the point of studying organisms that are all died? Not to mention plants.
Yes, that's a great point. Thank you very much. We need to be not just fixated on one part of organisms or living creatures. Absolutely. Thank you very much for bringing that up. So since we're already over time, I want to thank all the audience for being here. I want to thank Isabel. I want to thank Zana for doing all the technical and administrative work. But I also want to advertise our next talk, which will be in November. Remember, our talks are always the first Friday of every month. So for next month, November, it will be the 1st of November. Our talks are always at 4 p.m. CET, European time. 4 p.m. and we will advertise it, of course, on social media and on our website. Our speaker will be Rita Kovas. Her field is evolutionary biology. She's from the Center of Investigation for Systemic Biodiversity, and she will be talking about living together, cooperation and conflict in the sociable weaver. Wow, that's a very attractive and enticing title. So we look forward
Don't
to
miss
listening to
it. It's
Rita.
amazing. It's amazing.
I'm already excited. So hope you will join us. Thank you very much again. And you can watch the recording later on our YouTube channel. Take care, everyone, and be safe.
Thank you very much again. Goodbye.
Thank you.